You never know, Virginia might be dying laughing.
You never know. I'm dying laughing right now.
She's like this. She's dying laughing, guys.
That's why I cover my face, because that's what I'm secretly doing.
I kind of only remember CPR, so
Yeah, I'm still technically certified, but I don't remember anything.
I only remember how to do CPR.
I've done it so many times that...
You giving people CPR?
No.
Oh.
Taking the class.
Oh.
I've done it like 4 times. I've been certified pretty much since 10th grade.
All I know is that you can do CPR to another one bites the dust.
And staying alive.
But
Staying alive.
I think it's kind of funny that you can do it to another one bites the dust.
Fun fact. At our wedding, that's the song we left to.
Really? You predicted that, Josh. I love that.
That was the one song I let Kenny pick. And then we did the walking in, our, like, the bridesmaids did the, you know what they did in The Office for
Yes.
Jim and Pam's wedding? Yeah, we did that. We had that song and they did that coming in. I did it. Kenny had no idea they were doing it. So, like, it started playing and I didn't obviously get to see his reaction, but everyone said he was, like, laughing because...
I love that scene.
Yeah, it was really funny.
And when he said it,
Because I told them when they were practicing, I said, when you practice coming in, you have to go in normal, like, at the practice, because I didn't want him to know till the day of.
Exactly.
So at the rehearsal, they played some random song so that he would have no idea.
I love that. And then when he was doing the Staying Alive thing, like, that's where I learned it from The Office. That one scene where he rips
Where the
away,
dude
like,
rips the face off and puts it on himself.
I love that. I love The Office.
Okay, let's see. This says, to find each point of discontinuity, which of the discontinuities are removable, not removable, and explain. So, obviously, we're dealing with stuff around the number 2. Okay?
I was about to say X.
So, I'm looking at the limit as x approaches 2 from the left. And from the left, x is less than 2, so that would be of 3 minus x. So we'll look at that. Then I'm going to look at the limit as x approaches 2 from the right, which would be x over 2. And then I'm also going to look at the limit as x approaches 2 of f of x in general. So, as we approach 2 from the left, meaning we're at like, what, negative, nope, not negative, 1.99999, something like that. What would this be equal to? Approximately. 1. As I approach 2 from the right, that would be like 2.001 divided by 2, which would be 1. Do we understand where I'm getting the equation for left and right from?
Yes.
So x is less than 2, that would mean it's from the left. So that's how I chose that one. And then this one, x is greater than 2, that would be from the right. So that's how I chose that one.
And how are you getting that it's 1?
Just by plugging in a number
Oh.
that's just to the left of 2 or just to the right of 2. And then solving it. It's just like substitution like we did in whatever section 1 it was, I think.
Okay.
So then, if both one-sided limits are equal to 1, what does the two-sided limit have to be equal to? 1.
Sandwich.
I don't think that's it.
That's
No.
not the sandwich theorem, but
That's not-
good try.
I guess she thinks it's sandwiched in between, so.
I mean, it is, sort of.
Wait,
Sandwich.
guys, let me redeem myself. It has to have a trig function to do the sandwich theorem.
Pretty much, yeah.
Does this have any trig functions?
I'm not going to say 100% of the time it's a trig function because there could be a different function, but it has to be like a function and a function.
Yeah.
Pretty much for you to do it.
Love sandwiches.
All right, so then part A says find each point of discontinuity. So to do that, what I need to do is I need to look at f of 2 because I already know what happens as x approaches 2. But what is f of 2?
2.
2. So that's coming from up here. So when x is 2, it's equal to 2. So this is equal to 2.
2. Good number.
That's a good number. So then I need to know if there's a point of discontinuity or not. What I do is I compare the limit as x approaches 2 of f of x to f of 2. And I want to know if these things are equal to each other. So the limit as x approaches 2 of f of x was 1. F of 2 is 2. They are not equal, so it is discontinuous.
So
What's
we
going on out there?
I'm curious too.
I don't know.
They're all running.
Is it raining?
Oh, it's like sprinkling. That combined with like the sirens, I was like, what?
I know, I was starting to get worried. I was like, is it a tornado siren? Do we need to run?
Yeah, they're all like sprinting inside, but there's just like a couple raindrops.
Yeah, like what are they just afraid
They're
of
all like,
little
Is it little kids?
The little water.
no, these are like third
Those are
and
the
fourth
big
graders.
little
Oh.
Fourth graders.
Those are the big little.
They're probably like, my hair.
They're all running in like this, and there's like 3 little raindrops on the window. That was a lot at once. Like there was a whole like group of screaming and the sirens.
I know, that's why I was starting to think, I was like,
I
huh?
was thinking, wait, did someone die out there?
I know. At first I thought they were like, it was one of those days where the police come to like talk to the little kids or whatever.
But why would they have the sirens on?
Well, sometimes they show them like the siren and
Yeah.
stuff.
But it sounded like it was moving too.
We did that one Sunday at church. We had a fire drill at church.
I've never had a fire drill at church.
Well, we did it in the nursery so that like the kids and the workers would know what to do if we like ever had like a situation. And it was funny. So we were the little kids in the nursery, like the little nursery, get put in the rolling cribs and they get rolled outside. And then like the older kids, we just like line them up and we walk outside. But we had this kid that was like a massive runner, so we had to like somebody who had to be like designated to him, like.
Really?
Yes, to be like make sure he didn't like take off to the street, and all of our security team at church was like out on the perimeter making sure he didn't end up in the road because we're like on a main road. And so we like went out and they had a fire truck there and stuff like that so that the kids could like
Yeah.
learn about the fire truck a little bit and like learn to like not be scared of it and like how to listen if like a firefighter's telling you what to do if there ever was a fire, even at your house or whatever. And so it was pretty cool, but it was just funny. I've never done something like that at church, and like I don't even really do that at school, obviously, since I teach high school. Like we're not going out to look at fire trucks, sorry. Like
Like I've never heard of that.
it was just so funny. I was like, we're having a fire drill?
Like, really?
We even talked about not like a lockdown situation, but like what we would do if there was like an intruder or like if how do they call it, a disorderly individual in the church. It was quite funny.
I guess you wouldn't really know if there's a true intruder, like unless
Yeah,
they just
I guess
say,
you can't like.
Typically.
I guess you can't really call someone an intruder in a church. You know, 'cause
Well, yeah, I mean like
Yeah, like
intruder's not really the right word, but like somebody that's why I said disorderly,
Yeah.
because that also we do the same thing. Pretty much you do the exact same thing, other than sometimes it's get down and sometimes it's get up. So if somebody's like sick or something or like injured and they need to like remove them from the situation, like if we need EMTs or whatever and we can move the person, obviously there are times you can't, but like if you can, then we like everyone stands up and starts singing.
What church is this?
It's my church in Gloucester.
Okay.
Wait, why do you start singing though?
Because like there's like this one song, so like the person that plays the piano is like designated to go start playing this one song and like singing, so everyone will sing, so it just like eliminates the distraction. Because we had somebody that something happened like a couple years ago now where like this girl had like never had a seizure before, and she had a seizure like in the middle of church, and the parents were like, somebody help, she's seizing, and like in the middle of church, and everyone was just kind of like awkwardly like, I'm like, well, I know what to do, but like I'm guaranteed there's somebody that's better trained than me, so I'm just gonna sit here unless no one else gets up, then I'll go help.
Yeah.
But like there was a bunch of like nurses and doctors in there, so like they all went over, and like and even an EMT was in our like in the service, so they went over and then they called 911 to come and all that. But it was just like everyone awkwardly staring at them, and like the pastor couldn't even finish his
Yeah.
sermon because everyone was like so organized and stuff. And like if somebody's like posing a threat to the pastor, there's like a policy of like, okay, like everybody stay down, we're gonna sing still, but like everyone stay down while like the security team deals with it. I don't know, it's just a lot. So anyway, I've never done something like that at church before, but it's like actually you should do it apparently.
Imagine it's like your first day at the church. And they're like,
Yeah, well, they had to like explain to people that like this is just for practice so that everyone knows what to do if something
Yeah.
happens. But they did it once, I feel like, and it was over the summer when like everyone was out. So I feel like they should do it again
Was that this summer?
to like just go through the process. But anyways, random rabbit trail since kids were screaming. Anyways,
Children.
Yeah.
all right. Which of the discontinuities are removable or not removable? What do we think about this one? Do you think it's removable or not removable?
I think that's one of the removable ones.
Why?
Because, like, you have your function, it just, it goes, and then it just goes poof, and then it goes again.
Mm-hmm. Yeah, because basically, so this is removable. I'm going to see if I can give you a rough sketch. It's because f of 2, we said is equal to 2, but the limit is equal to 1, basically. So it shows you that it's not the same thing. So a rough sketch. Go up here so I can see it. So basically, I would have less than 2. So on this side, the intercept would be at 3, and it's got a negative slope. So there's a hole there. Then at 2, it is 2. So that would be here. And then the greater than 2, well, it would have an intercept of 0 with a slope of 1/2, so up 1 over 2, which would put it at the hole, and then up 1 over 2, and that would essentially be a line. So, and obviously I could keep going, but I have my hole here, and I only know it's a hole because it tells me that this is the function when x is less than 2, x is greater than 2, so I know that there has to be a hole there because that point can't actually exist there.
So how were you graphing those points?
Well, those are just equations of lines. 3 minus x would be like negative x plus 3. So I just graphed that like I would graph a line, but I put a hole there because I know it doesn't exist at 2,
Okay.
only less than 2, and then the other one only exists at greater than 2.
Okay.
So that's why. Does that kind of make sense?
I think, yeah.
And like obviously it would be really hard if it was something else. Like if it's a parabola, you could kind of graph it like on a rough estimate. But a lot of things you'd have like a hard time graphing, So
What does one
gonna
look
put-
like that's like non-removable? Like,
so non-removable would not have this middle point, essentially. That wouldn't be there. It would just be at something less than 2 and something just greater than 2, for example. So if this middle piece was missing altogether, then all that would happen is that would be gone and it would look like that. So there's nothing to fill it. Removable means that something can fill that value of that place that we're doing. So, and sometimes like 23 and 24 are the same type of question, but they give you the graph and you're looking at the graph instead of looking at the function. But I think it's easier to look at the graph and be able to tell what's going on personally than to have to sit there and calculate it. So that's why I did that. Let's see. It also can be not removable if the one-sided limits are different. So let me see if I can put this up here really fast for you to see. It's going to have the answers, but that's fine for this. Okay. So, well, you can't really read it probably, but Okay, so this is the graph that they gave us here. So notice that at 1, we have a hole up here, but then I have this filled spot down here, okay? So, and then over here it keeps going. I have a hole filled up here, and then it keeps going. So, essentially, the question was find the points of discontinuity. So the points of discontinuity are points not in the domain plus 1 and 2 because there's a hole there.
Okay.
So then the second part was which are the discontinuities are removable and not removable. So here, this one is removable because I have a value that can fill that spot, right? Because it's directly above. And the two-sided limit. So if I look at as x approaches 2 from the left, it's equal to 1. As x approaches 2 from the right, it's equal to 1. Then I have this spot up here. The difference with this piece right here, where this hole is, this one is not removable, and that's because the left or the left-hand limit would be equal to 2, but the right-hand limit is equal to 1 because there's nothing connecting this up here.
Okay.
So the limit as x approaches 1 from the left is 2, as x approaches 1 from the right is 1.
Okay.
Those aren't the same, and so it's not removable.
Okay. So that line or those 2 points would have to be connected for it to be removable.
Mm-hmm. Like this, or there would have to be something else coming off of this at a minimum. So yeah. So that's the other situation. I don't really think there's any other situations where it's not removable that I can see directly or that I can think of. I think those are the 2 situations. The most common one we see is, if there's just not a point here at all. But then like this one, obviously, there is a point, but it's not, the two-sided limit's not the same. The biggest thing we're checking is the two-sided limit.
Yeah.
So,
Okay.
okay. (26) Give a formula for the extended function that is continuous at the indicated point. So 26 f of x equals x cubed minus 1 over x squared minus 1. And they want us to do it at x equals 1. So essentially, what they're telling me to do is to factor and give, like, when they say an extended function, something that is essentially expanded. Because if I plugged in 1 right now, what happens?
Scary sentence.
Yeah.
I get 0 over 0, right?
Yeah.
But even just a 0 in the bottom is a problem. So I need to factor top and bottom. So, do we remember what the top would factor into?
X minus 1
Uh-huh.
x or times x plus x squared plus x plus 1.
Yeah, and obviously it would be 1 squared, but it's just 1.
Yeah.
So good. I didn't know if y'all would remember how to do that, so that's good.
I half remembered, but also
Same opposite, always positive. It's
Yeah,
the
I-
soap
I
formula.
I remembered the soap, but
That's
I
why
forgot
when
how
you
to
went
use it.
soap, or you said same, I was like, yep, she knows what she's doing.
Because I just studied that one a lot, because I wanted to make sure I remembered it for the quiz, and then I didn't even really need it, I don't think.
Yeah, I remembered the soap. I remembered what the soap meant, but I forgot how to use the soap.
So
So,
Josh,
like my hands aren't clean anymore, you know?
what's the bottom?
So, let me think. Perhaps we have an x minus 1 and perchance an x plus 1.
So then we cancel.
You're canceled.
And so my extended function would be y equals, or f of x equals, x squared plus x plus 1 over x plus 1. Because when I plug in 1 now, no problems. Now,
Although whenever she gives us homework, we have lots of problems.
true. 28.
Math teachers they give so many problems to their students.
They have a lot of problems.
Yeah.
I have a lot of problems. I'm
They
a math
dump the
teacher.
ball on their students too.
Yep.
That's why they're so scary sometimes.
I gave a class yesterday. I don't even remember what class it was. Like, probably 10 problems. And they were like, this is a lot. I was like, they shouldn't take you that long. They're quick. It was like square roots. I was like, what?
Oh, so what was it, like Algebra 1?
Yeah, I don't think it was that class, but like they did say something about it the other day when I gave them like a decent amount of problems. Like, guys, these are super easy.
Yeah.
I was like, I would think you should finish this in 15 minutes.
Like when you give us lots of problems, it's like you kind of expect them to be easy.
Yeah.
Because like you normally
Or
don't
there's
give
just
us
a really big variety that you need to be able to do, but I also don't normally give you like crunch time to
Or
get
you
them
give us,
done.
Like, more that you just say like as long as you know what you're doing.
Yeah.
I'm not sure if I knew what I was doing with the sandwich.
I have to.
It's pretty much just write it as 1 over whatever the denominator is compared to the whole thing, compared to the negative version of it, and then just figure out what that is, and then that's the answer. It's pretty easy. I mean, it's meant to be easy.
So we just totally disregard the trig function.
Pretty much, yeah.
Okay.
All right.
I like that. I like disregarding trig functions for sandwiches. Tasty.
This one is super weird.
Oh.
Because what can I do with this? Or what can I not do with this?
Well, I mean, you can't just cancel the
plug it
x's.
in.
Yeah, can't plug it in.
Can you use like the double angle thing, or is that only if it's 2, like sine 2?
Well, I mean, that's a double angle.
I mean,
Yeah,
maybe,
can't.
but
I don't remember how to do those. I forgot those.
I know the double.
this
angle
one you
too.
kind of are just going to have to take my word on it.
That means there's no shot for me.
I think I trust you.
So essentially, I'm saying that x can't be 0 for sine of 4x over x.
That's
But I need to know what it can be equal to essentially when x is 0. What the whole function would be equal to. Any guesses? I'm going to give you a hint. It's only a number. No letters.
My heart wants to say 1, but I doubt that that's it.
That's what I was gonna say too.
How about 4?
I was gonna
Because that's the
guess
number
that.
that's in there.
Darn it. I should have gone with my mind, not my heart.
These ones are super weird. You very rarely see them, but I just wanted to show you this one.
Imagine we had like 20 of these on the AP
I
exam.
know.
No, you won't.
Is that all we have to do?
Mm-hmm.
Oh.
All right, the last thing says to use Theorem 7 to show that the given function is continuous. So Theorem 7 was the composite function theorem that said if f is continuous at c and g is continuous at f of c, then the composite function g of f is continuous at c. So, that being said,
What was so scary,
What
Josh?
what was said?
I said that being said.
Right. What
Composite function.
let me see this. Where are you?
I promise it's way easier than you think it's about to be.
Yeah, I'm sure it is, but my brain did not really brain.
I want to show that this function is continuous. So I need to split this into 2 continuous functions and say, by Theorem 7, this is continuous.
Oh.
So, do you remember when we decomposed functions last year in pre-cal?
Do you?
We took a function and we split it into its 2 component parts.
Oh yeah.
Okay, that's what we're doing.
Ah.
So g of x
Oh, yeah. I remember.
is the function as a whole. It's the outer function.
Right.
So what is the outer function?
Sine.
Yep, sine of x. h of x is the inner function, and I'm using g and h since they used f to begin with,
They already took the F, so we have to.
so I have to use something else.
we just
So,
go down the
what is the
alphabet.
inner function?
Got this, Virginia.
I feel like it's more than just what's there. I can't think. Is it just x squared plus 1?
Yes.
Okay. I didn't know if I had to.
It's just what's left over.
Yeah, it's just the leftovers, Virginia.
Got
Don't forget.
Okay,
the
so this is the, so basically f of x is equal to g of h of x. Okay, so our theorem says if f is continuous at c, so if g is continuous at whatever the letter is or the number that they give us, not letter, and g, or in this case h, is continuous at h of whatever, then what we have is, or actually they have it backwards. Hold on. Let me restate that one more time. Okay. If f is continuous at c, so if h is continuous at whatever the number is, okay, and g is continuous at h of whatever that number is, then the composite function g of h of x is continuous at c. So this is continuous, right?
Mm-hmm.
Yes.
This is continuous. This is also continuous, right? It's a parabola and a sine function. Both of those things are continuous. So since they are both continuous on their own, that means that by theorem 7, g of h of x is continuous. I don't think Josh believes me.
Oh, I believe you. I mean, I know that those things are continuous. It's just that seems like a very weird way to prove that something is continuous. And I just wanted to see what a parabola and a sine function would look like.
All right. Problems are 1, 3, 11, 13, 21, 25, and 35. You may also, just for reference, want to look at 23 because that's one that was like 24 where you just had to look at the graph instead of having to solve it out like we did in 2020. So you may want to look at 23 as well, just for reference, but anyways. And 2.4 notes you need on Monday. So.
3 question mark 35.
I think I put up a quiz date up there for next Wednesday, but I think it's up there for Thursday, the 3rd. And then we'll probably test that following Monday or Tuesday.
Okay.
So
this is what that sine, that